This is Dr. Karnik with New Ed Science Academy. And in today's session, we are going to be looking into intermolecular forces. The first intermolecular force that we will be looking into is the London dispersion force. So here I have drawn 3 helium atoms to explain about this London dispersion force. Now, London dispersion forces are going to be present in all molecules, and they are the weakest type of forces that you will see amongst all the different intermolecular forces. So for that, what we are doing is we are zooming inside the molecule and looking at the atom level, because what's happening in the atom is going to be responsible for this London dispersion force. So let's look into this helium atom and think of it like I'm a photographer taking pictures of this helium atom as the electrons are moving around the nucleus. So I have taken 3 snapshots of this helium atom when the electrons are moving around the nucleus. In the first snapshot, here I'm seeing that the electrons are present. You know, helium has 2 electrons. One electron is present here and the other electron is present here. In the second snapshot, I see that this electron has moved and it is here. This electron is somewhere here. And in the third snapshot, I find that one electron is here and the second electron is somewhere here. Okay. So now in this third snapshot, what I'm seeing is that both the electrons are on this side, right? And because each of the electron carries a negative charge on them, this side of the atom is going to have a slight negative charge, and a slight charge is shown by this delta value. So whenever you see delta, it means there is the slight charge present here. Because both the electrons are on this side of the atom, this side is going to be slightly negative. And because the electrons have moved on this side, we know that this side of the atom is going to have a slight positive charge because there are no electrons present on this side. So now in this case, this helium atom has a slight negative charge on one side and a slight positive charge on the other side. Now we zoom out of the atom and now we are looking at the molecule. So in this big molecule, which has many atoms present inside it, if these atoms at some given point, again, we are taking snapshots at different points, right? At some given point, you know that all these atoms are going to have their electrons on this side, okay? So now in this case, and it could be many electrons, right? Depending on the molecule we are looking at, depending on the number of atoms that are present inside it, you got the point. Basically, all the atoms inside that molecule, if majority of them have electrons on one side, then that molecule is going to have a slight negative charge on this side and a slight positive charge on this side. And remember, this is going to be very temporary because the electrons are constantly moving. This is just one snapshot, one time when all the electrons happen to be on the same side. And therefore, the molecule has a slight negative charge on one side and a slight positive charge on the other side. Now let's see, there is another molecule wherein the same thing is happening. And at that moment, this side of this molecule has a slight positive charge and a slight negative charge. Now what's going to happen? Because of this slight negative charge on this molecule, this side, and a slight positive charge on this side of this molecule, there is going to be an intermolecular force attraction between these 2 molecules, right? This is the intermolecular force, which is the attraction between these 2 molecules, molecule A and molecule B. And this attraction is called the London dispersion force. And this attraction is going to disperse real fast. As soon as the electrons start moving, and now you no longer have one side of the molecule with a lot of negative electrons, the negative charge on that side of the molecule is going to go away. This intermolecular force is the London dispersion force, and as you can see, it is one of the weakest force because it doesn't last for very long. And this London dispersion force is going to be present in all the molecules. Let's look into the second type of intermolecular force, which is going to be a dipole-dipole interaction.